This is section 7.7, writing quadratic equations and functions. So we are going to have word problems again. I know you guys are so excited. So we're going to find the relationship between the roots and coefficients of a quadratic equation, and you're going to learn how to write a quadratic equation using information about the roots or a graph. Here we go. So, writing an equation given its roots, it's pretty simple. So if you were to be given an example here, how would you write an equation with given roots of x equals 1 and 2? If you think about it, you just have to go backwards. So your equation would have to be x minus 1 times x minus 2 equals 0, which makes sense because this will yield you roots of 1 and 2. So you just go backwards. Now that you have your factors, you just multiply them together, and this is what you get. X squared minus 3x plus 2. So there's a pattern here that you will recognize, and it's encompassed in this theorem. A quadratic equation with roots r1 and r2 is this: x squared minus the quantity r1 plus r2x plus r1 times r2 equals 0. Or it's going to be some factor. That's what a represents. You can multiply this by any constant number and you're going to get the same roots. So essentially what you're doing is it's a times the quantity x squared minus the sum of the roots r1 plus r2 times x plus the product of the roots r1 times r2. And if you go back to the first example, you will see how that works. Now let's take a look at some other examples. So find the quadratic equation with integral coefficients, and that's key, having the given roots 1/2, negative 5/2. So this is the formula you want to use: x squared minus the sum of the roots plus times x plus the product of the roots. So let's just plug them in. X minus the quantity 1/2 plus negative 5/2 times x plus 1/2 times negative 5/2 equals 0. So let's simplify this. And 1/2 plus negative 5/2 is negative 2. 1/2 times negative 5/2 is negative 4. So let's multiply everything by 4. This becomes a positive 2 times 4. So this yields you a 4x squared plus 8x minus 5 equals 0. So all you have to do is take your two roots. For the x term, make sure it's minus the sum of the roots times x plus the product of the roots, and get rid of all the fractions by multiplying all the denominators out. Let's try number 2. Find the quadratic equation with integral coefficients having the given roots. And we have a conjugate with a radical. 1 plus radical 5, 1 minus radical 5. And again, all you have to do is plug it into the formula. X squared minus the sum of the roots, which is 1 plus root 5, plus 1 minus root 5 times x, plus the product of the roots, which is listed here. Now you just have to simplify it. This is pretty simple. The root 5's cancel out, so you get x squared. This is a 2. So minus 2x plus, you get 1 squared minus root 5 squared as a difference of squares, so 1 minus 5 equals 0, which means x squared minus 2x minus 4 equals 0. So all you have to do, if you're given two roots and you're looking for the quadratic equation, just plug it into that theorem you just saw. Use negative the sum of the roots times x plus the product of the roots equals 0. Example 3. Now you have imaginary roots, but it works pretty much the same way. Go ahead and try to plug those in yourself and to figure out the answer. Be careful when you add and multiply the imaginary numbers. Alright, so if you plug in the formula, this is what you get. You have the sum of the roots here. Don't forget it's minus the sum of the roots times x plus the product of the roots. It's a very Christmassy theme here with the red and green. You know, the holidays are coming up. So you simplify, you get negative 3 plus I minus 3 minus I, so the i's cancel out. You get a negative 6 here. Negative 6 gives you positive 6x. If you multiply these two together, you again have a difference of squares. So negative 3 squared minus I squared. Negative 3 squared is 9. Minus I squared is minus negative 1. So you have a 9 plus 1. Your final answer is x squared plus 6x plus 10 equals 0. So don't let the imaginary numbers or the radicals trip you up. Just plug them in, treat them just like any other numbers, and when you are done, you should have integral coefficients. If you have an I or radical in your answer, you probably made a mistake somewhere. Alright, another problem. This time we have a fraction and a measuring numbers. I know it's making some of your lives a living hell. But go ahead and plug this into the formula and see what you come up with. Again, we are looking for an equation with integral coefficients, which means you might have to multiply out any fractions. Alright, so there you go. You plug those in and you get x squared minus 3 plus I over 2 plus 3 minus I over 2 times x plus the product of those two roots. Let's simplify. And when you add these two together, you have the same denominator, so you just add the numerators. 3 plus 3 is 6. I minus I is 0. So you have a negative 6 all over 2 times x. And again, you multiply the tops together. We just did that in example 3. This becomes 9 plus 1. You multiply the denominators to get 4. So you simplify this some more. You get x squared minus 3x plus 10 over 4, or 5 halves, equals 0. We want integral coefficients, so you have to multiply the entire equation by the 2 here in the denominator, and your final answer should be 2x squared minus 6x plus 5 equals 0. So again, don't let the fractions trip you up either. Just remember the formula. Sum of the roots goes here with the negative x. Product of the roots goes here, and simplify. Just be careful. And if you're really not sure and you have time, you can always use this equation, plug it into the quadratic formula, see that you get this for x. Alright, we have now a theorem. If r1 and r2 are the roots of a quadratic equation, ax squared plus bx plus c equals 0, then r1 plus r2 equals the sum of the roots. The sum of the roots will also equal negative b over a. r1 times r2 equals the product of the roots, which will also equal c over a. So again, the sum of the roots will equal negative b over a. The product of the roots will also equal c over a. So that might be a shortcut to help solve some problems coming up. Example 5. Find a quadratic function for the parabola with a minimum value of negative 1 and x-intercepts of 1 and 3. So this is a multi-step problem. Let's go through this step by step. First, we know that the function of x has to have an x minus 1 and x minus 3 in there because those are the x-intercepts. An x minus 1 and an x minus 3 in the factors will give us a 0 for f of x should we plug in one of these two values. Alright, we know that the minimum value is negative 1. This represents f of x at the vertex of a parabola. Remember that a parabola either has a minimum, if it's concave down or facing down, it is a maximum. If it is a U-shape opening up, the vertex is at the minimum. In either case, whether minimum or maximum, the vertex is there. So the minimum is negative 1. This represents f of x, or the y value, at the vertex. So we know this is negative 1. What about the x value at the vertex? Well, we can calculate that by taking the average of the two intercepts. If you imagine a parabola, it's going to cross the x-axis maybe twice. If it does, the vertex, because the parabola is symmetrical, has to be exactly halfway in between those 2 points. So the x-coordinate of the vertex has to be the average of the two x-intercepts. So take the average of 1 and 3, and you get 2. So now you have the minimum value for f of x. You have the x value at the minimum. Now you just plug those in and solve for a. So you get negative 1, which is the minimum, equals a, which is what you're solving for, times 2 minus 1 times 2 minus 3. All I did was take this value of x and plug it in from this equation. So if you solve for a, you get a is 1, because you get negative 1a equals negative 1. A is 1. Alright, so what do you do with that a value of 1? You go back to this equation, and you are going to now solve for f of x. So you get f of x equals a times x minus 1, x minus 3. We know a is 1, so plug that in, and you don't have to do anything with it because it's a 1. So your f of x is x squared minus 4x plus 3. So if you weren't sure on how to do that, go back and retrace those steps, because we're now going to look at the next example, and I would like to see if you guys can do this on your own. So example 6, I would like you to try this on your own using the steps you saw in example 5. So if you're not sure what to do, go ahead and look back at your notes and try to do it step by step. There's also an example on page 340 in your book. Alright, so the first thing you want to do is notice that the x-intercepts are negative 5 and negative 1. So we have to start out with this. F of x equals a times x plus 5 times x plus 1. we know those are factors of f of x because these two numbers, -5 and -1, would make f of x 0 if we put them in. So that's the first step. Now we have to do something with this maximum value. If the maximum is 4, this represents the f of x at the vertex. And you're going to have a negative a value because if it's a maximum, you're going to have a parabola that opens downward. So you're going to have a vertex at the very top. So this is the f of x. So how do we find out what x is at the f of x, where the maximum is 4? Well, you take the average of the two x-intercepts, -5 and -1, because the vertex has to be exactly halfway in between those two intercepts. So you take the average, and you get the x-coordinate of the vertex is -3. So we have the vertex -3, 4. All we do is plug those points into this initial equation we came up with and solve for a. So you plug in 4 for f of x, you plug in -3 for x, and you solve. So you get 4 equals a times this. So 4 equals a times 2 times -2, which is -4a. Divide both sides by -4, and you get a is -1. That confirms what we would have thought, because if the parabola has a maximum, again, is an upside down u, the a should be negative because the parabola opens downward. So now you plug the -1 in for a, and you solve for f of x. You multiply the inside together to get x squared plus 6x plus 5. Distribute the -1, and your f of x for this problem is -x squared minus 6x minus 5. So again, the steps are: come up with an initial equation using a and the factors for the x-intercepts. Use the minimum or maximum value that they give you. Find the x value of the vertex by averaging the two intercepts. Plug them into the original equation, solve for a, plug a into here, and distribute all of the factors. Alright, now we have 4 word problems we're going to do. First of all, find two numbers with sum 24 and product as great as possible. Now you may not be quite sure how to start this, so let's do this. Let's call one number x and the other number has to be 24 minus x because these two numbers add up to 24. Now we want to know how great the product can be, so we have to multiply them together. Let's call the product p sub x, or p of x. So p of x has to equal x times 24 minus x. Once you distribute it, and I'm going to put the squared term first, you get -x squared plus 24x. Great, what do we do with this thing? Well, you know that a is -1, so the vertex is at the maximum. You have a parabola, if you were to graph this, that opens downward, so the vertex is at the very top. You want to know the x-coordinate of that maximum. Now, if you remember back in section 7.6, I told you that the maximum or minimum of any parabola is where x equals -b over 2a. And keep that in mind. That's going to be your friend in this lesson because you're going to use it a lot. So, remember, b represents the coefficient for the linear term or the x term. The a represents the coefficient for the quadratic or the square term. So here our b value is 24, our a value is -1. So our x is going to be at 24 divided by 2 times -1, negative the whole thing. So let's simplify this and you get x is 12. So the two numbers that will add up to 24 and have the maximum product are 12 and 12. X is 12, 24 minus x is 12. And if you think about it, this makes sense. You're going to have a square that's going to have the greatest area if you have coordinates. If you have a rectangle, you're going to have a smaller area. If you didn't make sense, you don't worry about it. Let's go to word problem 2. A pen is to be built along a wall from 72 meters of fencing. Determine the value of x that maximizes the area that will be enclosed. So, let's do this. You have a perimeter of a fence. 2 times the length plus 2 times the width is going to be 72 because that represents how long our fencing is. We're trying to build a rectangle. So 2L plus 2W equals 72. Now you will notice that you can simplify this. So L plus W then equals 36 if you divide every term by 2. I'm going to solve for L because I'm going to substitute for the L in the next equation. So L equals 36 minus W. All I did was subtract W from both sides. Now, we also know that the area of a fence is going to be the length times the width. I'm going to substitute 36 minus W in for where L was. So our area of this pen is W times 36 minus W. or 36w minus w squared. Now you want to know the maximum value of x or w that will get you the largest area, and do the same thing that we did in the last equation. You're going to have the maximum w at negative b over 2a. So you plug that in. B here represents the coefficient for the linear term of the w. The a represents the coefficient of the quadratic or the square term. So w equals 36, which is b, divided by 2 times negative 1, the negative of that entire fraction. So if you simplify that, w is going to be, or x is going to be 18 meters. And this makes sense again because you're going to have the maximum area using a length of fence when you make it a square as opposed to any rectangle. So again, use the formula for the perimeter and the area, do a substitution. You're going to want to get an area as a function of the width or the length or whatever. And then solve for the maximum by using this negative b over 2a formula. Alright, number 3. A rectangular dog kennel is to be constructed along a house with 60 meters of fencing. If the house serves as one side of the kennel, determine the greatest possible area that can be enclosed. Alright, with this low budget PowerPoint, this is the picture I came up with. There's your house. There's the wall of the house. These three sides represent the fencing that's going to have to add up to 60 meters. So, let's call this the W, the width. Let's call this here the length. So, we know that these three sides have to equal 60. This is also a W, so our perimeter will be 2W plus L equals 60. Now, in the same way, we can solve for L, and we're going to substitute. So, L equals 60 minus 2W. Alright? Now, we want the area at its maximum. So the area remains the length times the width. I'm going to substitute this value in for L, so we get the area equals W times 60 minus 2W, or 60W minus 2W squared. Alright, so far so good. Now we're at the same place we were in the last two word problems. Again, what you're going to want to know is the maximum area, in this case maximum because we have a negative value, negative coefficient for the W squared. The maximum is going to be at W equals negative B over 2A. So you plug those in. Here you have 60 for B, you have negative 2 for A. You solve for W and you get 15 meters. So that gives us the width where we'll have the maximum area. We know that the area equals 60 times width minus 2 times the width squared. So you plug in the 15. The question is asking for the area, and you solve and you get an area of 450 square meters. So again, draw a picture if you can, come up with a proper formula or an equation, use the maximum formula or the minimum formula where you have the W or the X at negative B over 2A, solve for that value, plug it in to solve for the area. Last problem, we have a physics problem. If an object is projected vertically upward with a velocity of 29.4 meters per second from a height of 30 meters, then its height h above the ground in meters after t seconds is given by this formula. H equals 30 plus 29.4t minus 4.9t squared. What is the maximum height that the object will reach? Alright, this problem looks more difficult than it really is because you're applying the same principles that you applied on the first three word problems. At what value of t do you think you're going to get the maximum h? Yep, negative b over 2a. What is the value of b here? 29.4. What's the value of a? Negative 4.9. Yes, this feels like an episode of Dora the Explorer. Alright, so you plug in those values for b and a, you get negative 29.4 over 2 times negative 4.9, and you get a nice round number for t, 3 seconds. Now, to find the maximum height, we plug in 3 for t and we solve for h. So h equals 30 plus 29.4 times 3 minus 4.9 times 3 squared. You simplify that and you get 74.1 meters. Alright, so in this lesson we did several things. First of all, you used the roots of an equation to find the function or the actual equation itself. Then you use the intercepts and a minimum maximum value to solve for a, and then come up with the value of a function of a parabola given some of those variables. Finally, we did a few word problems where you were given or you had to come up with an equation based on area or a projectile's height and find the time or the value of the width where you get the minimum or maximum using this negative b over 2a. Remember that. Write that on your mirror in your bathroom. Write it on your forehead so that you see it in the morning. Make sure you write it forward so you can see it in the mirror. Anyways, that's it for next section 7.7. If you have any questions, please ask me in class or email me. You will have a lot of problems to do because, yes, there are word problems. I can sense your excitement.